Okay, so guys, we're gonna just do a review, a recap of what we've learned so far. You're always gonna start with factoring in order to find the vertical asymptote and the holes. Okay, so first, this numerator can all be divided by x. And then I can do an eye chart. And I get 3 and -3 because those multiply to give you -9, but add to give you 0. So this numerator can be written as x times x plus 3, x minus 3. Okay, so this is the numerator factored. Now we're going to factor the denominator. I need two numbers that multiply to -3, add to -2, and that's -3 and 1. So that will be x minus 3 and x plus 1. So if I factor f of x, this is what it will look like. Okay, and look at what cancels. That and that cancels out. That means I will have a hole. So my hole is going to be the x value 3. And the reason why I know that is because whatever we cancel out, we set that equal to 0 and solve. So if you add 3 to both sides, you get x is 3. That is the x value of the hole. So let's go ahead and write the function. It is x times x plus 3 over x plus 1. This is the function we are now going to look at because these are gone. Okay, to find the y value of the hole, I'm going to plug in this 3 into this. So I will have 3 times 3 plus 3 over 3 plus 1. I plugged in 3's where all the x's are. This becomes 6, and 6 times 3 is 18 over 4. Can we simplify this? Yep, 9 over 2. So this is 9 halves. That is where the hole is. Okay, now in order to find the vertical asymptote, we're going to set this denominator equal to 0 and solve it. So for the vertical asymptote, we're going to do x plus 1 equals to 0, and then we solve. So the vertical asymptote is x equals -1. Okay, horizontal asymptote. Let's look at what we had in the beginning, or you can look down here. X and x is x squared, and there's an x in the denominator. So I know it's bigger on top. Also, if you look at the original, this has an exponent of 3. This has an exponent of 2, so it's bigger on top. Guys, when it's bigger on top, what's the answer? None. So we do not have a horizontal asymptote. Okay, so this is what we learned previously. Today, we're going to be introduced to slant asymptotes. Okay, so I'm going to pause here on this example and let's take some notes on slant asymptotes. Okay, so a slant asymptote occurs when the numerator is a degree higher than the denominator. And when I say a degree higher, I just mean 1 degree higher. So if you have x cubed in the numerator and you have x squared in the denominator, that's a difference of 1 degree. Okay, so when the difference is 1 degree, you will have a slant asymptote. You're going to use long division to find the slant asymptote. The quotient is the equation of the slant asymptote. Now, if you research this on your own, sometimes slant asymptotes are also called oblique asymptotes. Okay, these are synonyms of each other. You'll hear them called both ways, oblique asymptotes or slant asymptotes. Okay, so in our example here, our numerator is 1 degree higher than our denominator. That means we're going to have a slant asymptote. We're going to use long division to find that. So I'm going to erase this. Okay, so we're going to do long division. An excellent question was asked. do we use the simplified equation or do we use the original? It doesn't matter which one you use, okay? I'm just going to stick with the original. So I'm going to do x cubed minus 9x. Okay, so we set it up. And we're going to do long division. So guys, x squared times what will give you x cubed? X. Now we're going to multiply. X squared times x is x cubed. Negative 2x times x is negative 2x squared. Negative 3 times x is negative 3x. Now we are going to change these signs. This will become negative, positive, positive. Those cancel out. Can these combine? No. Do these combine? No. So I'm just going to bring down the 2x squared. That doesn't combine with anything. But these combine. What's negative 9x plus 3x? Negative 6x. Okay. Now we start again. Let me highlight it for you. X squared times what will give you 2x squared? 2. So I'll put a 2 on the top, plus 2. And then we're going to multiply again. X squared times 2 is 2x squared. Negative 2x times 2 is negative 4x. Negative 3 times 2 is negative 6. Go through and change the signs. That canceled out. Negative 6x plus 4x is negative 2x, and you can just bring down this 6. Okay, can I do this part again? Okay, so this is your remainder. You don't need to worry about the remainder, because let's look back at what the note said. The slant asymptote, the quotient is the equation of the slant asymptote. You don't have to worry about the remainder. This right here is your quotient. This is your quotient. That is the equation of your slant asymptote. So for slant asymptote, I'm going to put y equals, and my quotient is x plus 2. X plus 2. Okay, and I got that from up here. This is the quotient, x plus 2. So guys, let's go ahead and graph that line. Remember from Algebra 1, y equals mx plus b? This is the same format. So guys, what is your y-intercept? 2. So this is the point 2, and then I'm going to go up 1 over 1. So this is my slant asymptote. Remember, the definition of an asymptote is it's a line that you cannot touch. So our graph will not touch this line. That is our slant asymptote. Now let's go ahead and graph our vertical asymptote. All right, so that is our slant asymptote. Vertical asymptote, x equals negative 1. So on the x-axis, I'm going to go to negative 1. This is a vertical asymptote. Okay. Oh, did we figure out our x-intercepts? Let's figure out our x-intercepts. Do you guys remember how to find the x-intercept? Yes, you set the numerator equal to 0. So for x-intercepts, I'm going to use my simplified equation. Set this x equal to 0. So I get x equals 0. So one of them is 0, 0. And set this part equal to 0. If you solve, you subtract 3, you get x is negative 3. So my other x-intercept is negative 3, 0. So let me plot those. This one is 0, 0. And this one is negative 3, 0. Okay, so I know that my asymptote will most likely look like that, or my graph will look like this. Going along the asymptote, but not getting close to it, and going through those x-intercepts. That's my slant asymptote. Okay, now let's figure out the domain. Domain is left to right. So on the left side, let me use my highlighter. The left side is over here. That's negative infinity. It gets close to what? 1, negative 1, yeah. And then it picks up again at negative 1 at the asymptote, and it goes to infinity. So I'm going to write that down. Negative infinity. Do we have a hole? Oh, we do have a hole. We have a hole at 392, 3 9/2. So let me graph that. 3 9/2 is what, 4.5? So I have a hole about right here. Make sure you add that hole in. So negative infinity to the asymptote, -1, 2, -1 to this hole. It stops at the hole, so 3. Let me write it over here where I have space. Negative infinity to -1, union, -1 to the hole, and then the whole to infinity. That is how you write your domain. Now let's talk about the range. This graph goes forever down, and then it goes, on this side, it goes forever up. So that'll be all real numbers. However, y cannot be what? -9/2, because there's a hole right here. Oh, sorry, +9/2. That's where the hole is. Okay, so how we're gonna write it in interval form? You can write negative infinity to that hole, 9/2, and then continue after the hole. So that is your range. Okay, let's do another example of finding the slant asymptote. All right, so we have -8x² minus 12x plus 7. How do I know I'm going to have a slant asymptote? Yes, the degree of the numerator is 1 degree above the denominator. All right, guys, so -4x times what will give you -8x²? 2x, perfect. Now we multiply. This times this is -8x². This times this is -8x. We are going to go through and change the signs. Those cancel. -12x plus 8x is -4x. Bring down this 7. All right, that was the first round. Now for the next round. -4x times what will give you -4x? A +1. Now we multiply. This times this is -4x. -4 times 1 is -4. Now we're going to go through and change the signs. That cancels and I get 11. Does my remainder matter? No. The slant asymptote is up here. This is your quotient. So that is the equation of the slant asymptote. So this is 2x plus 1. That means you start at 1 and your slope is 2, up 2/1. This is your slant asymptote. So your graph will not touch this line. Okay. How do I find the vertical asymptote? Yep, set the denominator equal to 0. So this is my denominator. If I set it equal to 0, I can add 4, and I'll get -4x equals 4 divide x is -1. Okay, so it's also not going to touch this line. Okay, guys, we don't really know which side or how we're going to draw this. We need to plug in some points. So let's plug in the easy point 0. Let's plug in 0 and see where it is. If I plug in zeros everywhere, what do I get? 7 over -4, which is what? It's going to be a negative number, right? So it's over here. -1.75. Perfect. Okay, so around here somewhere. So I just plugged in a random point. So I'm assuming that it's going to look like this. It's going to go through that point and go along the asymptote. Okay, let's plug in another number. You can plug in a number like -2. Oh, we don't know if that's there. But if you plug in -2, plug in a -2, calculate what that is, and that'll tell you where the point is. But I'm just gonna let you know it goes like this. Okay. Next example. Next example, write it down, please. We have 2x cubed plus x squared minus 9x minus 4. Okay. X squared minus 3x plus 2. Okay. X squared times what will give you 2x cubed? Yep, 2x. 2x. Now we multiply. This times this is 2x cubed. -3 times 2 is -6, and those two x's are x squared. 2 times 2 is 4 with an x. Now I'm going to go through and change these signs. So this will be negative. This will become positive. This will be negative. All right, those cancel. X squared plus 6x squared, that's 7x squared. This is -13x, and I'll just bring down the next thing. Next round, x squared times what will give you 7x squared? 7. We're done here, but if you want to keep going, we can. This is your answer. But x squared times 7 is 7x squared. -3x times 7 is -21x. 2 times 7 is 14. Go through and change the signs. I'm left with 7x minus 18. This is your remainder. We can't do anything else. We can't multiply. We're done. Okay, so 2x plus 7, that is your slant asymptote. So let's graph it. 1, 2, 3, 4, 5, 6, 7. You go up 2 over 1, up 2 over 1. You can go down 2 this way. This is what your slant asymptote would look like. That is where your slant asymptote would be. Now, if you want to be able to graph this fully, you guys are going to have to factor this, okay? And can I erase this part? Y'all have it? Can I erase it? Okay, the slant was 2x plus 7. This is the slant. Oh. 2x plus 7 was a slant. Okay, if you wanted to factor all of this, for this one, you'll have to use grouping. So that's 2x cubed plus x squared minus 9x minus 4. Split it. You guys remember that? Okay, you would have to do grouping. But you guys won't have to do this. This is just a difficult one. Oh, can we not? Oh, not this example. Okay, I'll pause here. So you're not going to get this type of one on the test. I just wanted to show you what it would look like. So you guys know how to use long division to find the slant asymptote. So you guys are going to go ahead and do the practice. There's many practices for you.